Morning everyone. Today I'm going to be doing a little bit of speed matching for my locomotives. I have two goals for this. The first goal is that all the locomotives run at the same speed, at the same throttle setting. So I can run trains interchangeably or locomotives interchangeably and run any locomotive with any other locomotive. Second goal is I want the scale speed to match the throttle setting. And I'm going to be doing it as a percentage on the throttle. So I have my DT602D from Digitrax, but it would also work with engine driver, anything else. If you notice, I have it set at the speed at percent. So I want 40%, not 40 speed steps, but 40% on the throttle to represent 40 scale miles per hour. And I want 30% on the throttle to represent 30 scale miles per hour, and so on. 20% would be 20 scale miles per hour. So I have those two goals in mind, and I've done a few of these already. Today I'm going to be doing an Athearn SD70N. This is roll number 1923. And this is JMRI. I'm going to be using JMRI exclusively to do the speed matching. And this is the programmer for 1923. So I don't know if you can see that, but that's 1923. That's where we're at. We're on ops programming, so we can program on the main line. And using V-start, V-mid, and V-high. I'm going to leave V-start and V-high alone. And I'm just going to be changing the V-mid. And I'm going to, this is the factory settings, which is a little slow, I found out. So I'm going to change the V-mid to 100. And I'm picking 100 because I've done this with a couple engines before, and most of the Athearns are somewhere around 100. So I'm going to start there, set that at 100. And then I'm going to use these speedometers. These again are JMRI speedometers. And this will basically measure the speed, the scale speed of the locomotive going from one sensor to the other. LS36 is a sensor for the control point from one set of signals to the other set of signals. And it's 70 inches between those. L37 is the next detection block past the signals. So L36 is when it enters the control point. L37 is when it exits the control point. And then it will determine the scale miles per hour as we go through there. It's 70 inches between the signals. So it's going to be traveling a total distance of 70 inches, which if you do the calculations, comes out to 507.5 scale feet. All right, so we're going to see how 100, going to clear this. Here it puts the scale miles per hour. This is for going from left to right. This is for coming back from right to left. So just a little bit of change in the sensors. All right, so we're going to, now I should say down here, it shows you what the setting is. This is 128 speed step, so it won't be exactly what's on my throttle. I'm going to be going by my throttle. So I'm on 1923 on my throttle. You will be able to see the changes of the speed setting down here. It'll be a little bit higher than what I'm doing on my throttle. So anyway, I'm going to back up a little bit here first. Make sure we have a running start. And I'm going to set my throttle to 40% and see if we get 40 scale miles per hour. All right, came out to 42.4 scale miles per hour. So 100 is a little too fast. We're going to come back the other way though and see. I'm going to go forward. Got to make sure I have time to get it exactly at 40 before I hit the signals. All right, we're going to come back And we're going to be looking at this one here. You can kind of watch the lights come on as it enters and exits the different blocks. All right, so we're going to come back at 40. All right, we are at 40 now. All right, and so that came out to 43.1, so they're both high. This locomotive runs a little bit faster going backwards, but that's all right. All right, so we're going back to our programmer then. So 100 is a little too high. We're going to back it off to 95. Right, changes on the sheet. Minimize that, and we're back to here. It was clear and clear. Let's see what we do at 95 for the midpoint. All right. All right, we are at 40 right now. All right, it's entered the control point. And it exited. All right, still a little high, 41.1. Let's come back the other way. All right, let's see if I can hit 40. All right, we're at 40. All right, that's pretty close to forward. So I was still a little high, so let's back it off just a little bit more. Let's do 92. That may be too far, but we'll see. All right, minimize that, and let's back it up. Let's clear it too. Clear, clear. Get a good running start again. All right, coming back at 40. It's at 40 right now. All right, 39.7. I'm going to count that as close enough. I could do one higher. Let's see what it does going backwards. But that's pretty close. I think if I go one higher, it's just going to be over by the same amount. And let's come back at 40. I'm at 40. And so that's a little bit above. So I'm going to count this as good for 40 miles per hour. Now, just to double check, I'm going to see what it's going to be at 20 now. And see if it holds true for all the other ones. So we're going to go back a little bit more. All right, let's come through at 20. All right, we're at 20 right now. Yeah, they came out to 19.3. So that also is a little low. Let's see what it does coming back. That's probably far enough. If this is also below 20, I might up the midpoint speed step a little. We'll see. All right, that's exactly 20. So I'm going to count that as good. Let's just try 30 for fun. See what that comes out to be. Oops. Go this way for a second. And there's 30%. One thing I found with the HO locomotives, that Athearn and scale trains and Intermountain that I have, is that they hold pretty consistent going through. That's almost perfect, 29.7. When I did N scale, you had to put a new point in for every single scale miles per hour. Here, every locomotive I've done, let's come back. Yeah, 30. Every locomotive I've done so far has been spot on. Once you get 40 set, it's pretty good on the other ones. That was not the case when I did N scale. You pretty much had to use the speed tables and set it at each like a 10, 20, 30, 40, and so on. That's perfect. All right, so this one is good. And I have done a successful speed matching. So this locomotive should run consistently with all the other ones. Plus, it's kind of nice when I run the trains, I can have an idea of how fast I'm going by what the percent says on the screen. All right, we're going to go ahead and check it out for Locomotive 1574, which is also SD70N. I run this together with 1923 for right now. So I want to set this one as well. So go to the, as you can see, I went ahead and set this at 92. That's what worked for the 1923. Assume that it will work for this one too, but we shall see. All right, we're going to go ahead and run through at, let's back it up a little bit first. All right, come on through. All right, 40 now. Well, that's almost exactly the same as the other one. Let's come back and see what it is. I think the other one was 39.7 possibly. All right, it's at 40. So I'm going to, since they're both under 40, I'm going to go ahead and give this another point. See what one makes. Now, since it goes all the way up to 255, 1 percentage point is only less than 0.5% higher. So let's see what this does. Oh, clear. Now, you may be wondering how pulling a loaded train affects the scale speed. And it still matches because these decoders are set to maintain the same speed no matter what the load. So as it goes up a hill, it'll continue at the same speed. 40. So no matter how many cars you're pulling, if you have it set at 40, it should go 40 miles per hour. All right, much closer. That's better. I think I'm going to leave it here. See what it is coming back. All right, it's at 40. All right, that's pretty much perfect. I'm going to call that a win. And we're going to, I'm going to go ahead and put the two together and run trains. I've kind of found that the trains run faster than I expected. So I guess I'm used to N scale, so that's probably why it's a difference. But anyway, thanks for watching this video. Take care, everybody.